Welcome to a new entrepreneuring interview brought to you by the Arrowhead Center here at NMSU. I'd like to welcome our guests today, Charles and Anna Harb of RingIR. I appreciate you both stopping by the podcast.
Thank you. Thanks. Nice being here today.
Now, what is it that RingIR does?
RingIR is a spectroscopy company. We make instruments for the real world, and we look at the spectrum of gases so that we can tell you what gases are around you. We for example, let's say that you had natural gas coming to your house and you get a natural gas leak. Well, the instruments that look at that at the moment don't actually look at the methane. What they look at is something which indicates there might be methane. But what we do is we try to tell you that it's actually methane that's the leak. So as opposed to like smoke detector instruments and things like that, we can tell you what it is, and so you get less chance of having false positives, and you can trust the answers. So that means that you have more confidence that what you're getting is actually the thing that's actually there.
Now, I understand that you have a prototype that you developed at the Arrowhead Center. Is that what this device does?
Yes, we have more than one prototype, but the prototype we're building with Arrowhead is really almost like our flagship commercial instrument, and that's going to be a wideband instrument that looks at many chemicals, many gases at the same time.
What's interesting about the technology, as a non-technical person myself, that I found interesting was the concept of how it actually detects. Everything, as we know, is made up of molecules. And as such, everything has a molecular fingerprint. Well, that's what this instrument does. It detects and analyzes based on a molecular fingerprint. So similar to what you would find in a criminal lab, where they would take a fingerprint and they would match it up to a database and find out exactly who the criminal is. That's kind of how this works. And so it's a very interesting concept.
And then the Arrowhead prototype, the one we're working with Arrowhead on, has it's almost like a instrument that will let us see a wide range of chemicals, unknown chemicals, and gases. In the future, as we develop the company, we'll start making specific instruments that look for particular things that people are interested in looking at, like natural gas, for example, leaks. And working with groups like the oil and gas industry, the natural gas industry, all these different groups that need to know if their instruments are doing the right thing, and if those instruments can tell them that they have a problem before that becomes a real problem.
Now, I understand that you came through the Biz Print Program, which was also supported by the New Mexico Gas Co. What was it like going through that program?
It was very good. It was very good. One of the things that it really enforced was getting out into the field, leaving your office environment, and getting out and talking to prospective buyers of your product or service. And this was very good to us because we could have come up with a very comprehensive list of exactly why everybody would want our product, right? It would be the greatest thing since sliced bread. We know that you need this. But unless you go out and actually talk to your customer base, your prospective customer base, you really don't know what they think value in the product is. We could list a bunch of stuff, but we found out that none of it, or not, I wouldn't say none of it, but a lot of it wasn't necessarily high on their priority list. So we could have ended up going forth making a product that nobody would really want to buy because it was what we thought they needed and not really understanding what they really needed.
Oh, so did it come naturally to you to go out and explain exactly the product that you were creating to new people who were unfamiliar with it?
No, and yes. So it depends. There's from the engineering science point of view, this type of desire to have a molecular machine that does very sensitive molecular fingerprinting has been around since you may not believe this, but thousands of years. The first time people thought about this type of thing, even though they didn't know molecules existed, was way back in ancient times when they realized that just by smell, you can tell if somebody's sick or somebody has a problem. So, and we know this from canines and other things that just by the smell. So the actual science part and the engineering part was just trying to mimic what we could tell and, naturally. But then explaining it to the real world is a much harder thing, because people walk around, people see their environment, because you can't see the gases you're walking through or the things you're walking through. You just open a door, you walk in. We're not trained to realize that there could be something bad on the other side. And so that's different. That's really getting people to understand that just because we have an atmosphere doesn't mean it's always clean.
Now, to rewind a little bit, I'm curious, and we talked a little bit about how BizSprint helped you grow. Where were you at when you started BizSprint?
We started our facilities, our company in Albuquerque at the West Building, which is in an incubator in the middle of town on Broadway Avenue. And we had just started the process of taking the technology out of the university into the real world. And so having developed the technology, when you're in a university, you develop it up to a certain point. But there's a lot of other features in a company that, you tend not to think about. Like, for example, who's going to pay for it? Because you have the facilities. The universities tend to have the ability to do a certain amount of development of a product, but they're not really ready for the rest of the world. So we had moved out into our facilities in the West Building up in Albuquerque, and we started looking at what was available here in New Mexico. And one of our board members suggested that we talk to Arrowhead and start working with people throughout the New Mexico ecosystem. And we've just been very fortunate that all these connections have really helped us to meet a lot of people here. And that's helped us to look much broader to the actual clientele, as well as the assistance you can get as a small business here.
We had a bit of a staggered beginning. We were incorporated actually in California in 2013. But things really didn't start moving until we moved here in August of 2016. The technology came out of the University of New South Wales in Australia, so we were living there at the time, and we thought, okay, we're going to take the technology out of the university and create a company. Well, being a startup, and I'm originally from California, my family goes back generations here in New Mexico, but originally I was from California and Silicon Valley. And so we thought, well, we'll take the technology out of the university, create a company, head to Silicon Valley, because that is like the startup bed for so many companies. Well, when we got back to California after living 11 years overseas, we found California, the climate for starting up businesses in Silicon Valley had changed drastically. Everything was frightfully expensive to live, to start a company, to hire talent, everything that goes into it. And we knew that if we were going to break into the startup climate there, that not only would it be harder to get funds, but it would also we would go through funds very, very quickly. We'd probably be dead in the water within a few months because it would just be so frightfully expensive. So then we decided to try New Mexico. Charles had done some development on sabbatical in Los Alamos in 2011. And like I said before, my family was from here, so we thought, why not New Mexico? Well, we came here and we found a bit of a gold mine that is really not known outside of New Mexico. There's this fabulous resource of labs and brain power and programs like Arrowhead. And we've really found that we have definitely benefited from the move here, and we would not go out. We would not leave.
Now, tell me, let's talk about prototyping. What was the process like building your prototype at Arrowhead?
Very simple. It was a very easy process. We came down. We had a couple of meetings, described what we were trying to do and why we were trying to do it. We already had a lot of things to start with, so it wasn't as though we were starting from zero. So we could actually pass those things on to the mechanical engineers here and say, look, what we want to do is we want to do this, that, and the other. And we had just a general conversation to discuss how we wanted to do this. Very quickly, we had come up with a sort of a design that we could then 3D print. And now what we have is something where it's basically a beginning for what we would want to manufacture. But we also see all the improvements we could make just from one iteration. So we already know how we're going to change it to make the real instrument, seeing that now that it's a physical thing, we didn't have to go through and manufacture this thing, which would have been very expensive. We can now go to stage 2, which is all the improvements we can already see. So that process has been very easy to work with. And very fast. We started working with them, I think, about a month ago, and we're already moving very quickly now.
Had you had previous experience working with a 3D printer?
Well, depends on what you mean experience. I knew people who turned it on. Is that what you mean? No, we had already designed some work at the university using 3D printing. And so, but I mean, I was not the one actually doing that work. I was just telling people what they had to do. And so, from the design process, there was a team which I was directing, telling them, we need to build this and that and so forth. So we had already looked at that aspect. I could see the value very quickly in being able to prototype these things and not have to do all of the manufacturing. So to give you an example, the first instrument we built, which was like a subsection, took the mechanical workshop a year to build. We built the last one before we left the university in less than 24 hours. So that's the power of being able to build these things with 3D printing. You can move your production much, much faster through the cycle. And then when you make mistakes, it hasn't cost you huge amount of time in terms of labor or huge amount of cost in labor or huge amounts of time to see what the problem really is.
Yeah, I mean, that's just a staggering improvement in time invested.
Well, in the optics world, that's how much it takes. And so when you're talking about looking at instruments like this, there's a lot of stuff you have to do before you can actually make an instrument. So as a result, each one of those steps, if you're going through a standard mechanical design process, can be very lengthy. But if you do it this way, you can get it out very fast. And then you can see your mistakes really easily. It's like, oh, I did that all wrong. Let's start again. But you haven't lost 6 months of time.
Right. Mm-hmm. Well, Charles and Anna, thank you very much for coming by and sharing your story with us. It's incredible to hear how fast you've moved along.
Thank you.
Thank you.
And for everyone out there, if you'd like more information on BizSprint, visit arrowheadcenter.nmsu.edu/BizSprint. And for more information on the New Mexico Gas Company, same URL, but /NMGCO. Thank you again.
Thank you.
Thanks as always for watching. Don't forget to like and subscribe for more interviews with entrepreneurs. And visit arrowheadcenter.nmsu.edu to learn how New Mexico State University can help you launch your business.